into data. So these are just some admin stuff. If you have any question, you can stop and ask me. If something is not clear, anything. Yeah. And then I'm not waste my time in all of this. So as you program, you encounter several errors. So don't freak out. You know, whenever you get through and you see an error, don't now shout at me. Just calmly look at the error message. It should direct you as to what is the problem. For example, if you print something and it refuses to, if you forgot to close the write anything in Python and you encounter any error, just look at the error message. It should direct you as to what the problem is. So when we say Python, we're not referring to this. Yeah? And this guy was the person that invented Python. Guy Van Rossum. When you read about the history, it's an open source software, free of charge. And yesterday I mentioned that it's versatile. You can do several things with Python. Yeah, from data science, machine learning, software development, amongst many others. Particularly for us that want to do data science, we'll particularly be using several libraries such as NumPy, Pandas, Matplotlib, SciPy, Scikit-learn. So Scikit-learn is for machine learning, so we will not treat it in this class. Start model. And I mentioned that you can run Python with several ways. You can use the IDLE default environment, or you can use any third-party IDE like Python or Cider or Thorny or anything. Personally, I prefer using the Jupyter Notebook, and I think we've seen how it looks like, isn't it? And you know, when you have a Python file, it's saved as .py, isn't it? If you have a Jupyter Notebook file, it's saved as what? We say GB. It's saved as IPython, IPYNB. Okay? IPYNB, IPython notebook. For example, if you open Anaconda, okay, and this Anaconda, let's say I open.
Screen is not showing.
It's not showing. Yeah. I'm sharing my entire screen.
Yes, it is not showing. It is showing. Yeah, no.
What you was not showing? Because I'm like,
yes, yeah, connect to.
I'm sharing my entire screen, so you should be able to see whatever is in. Are you not seeing your screen?
Yes.
Can you see your screen?
Yes, I can see. Please, your screen.
Okay. So let's say I open Anaconda and I launch Jupyter Notebook. Okay? Like we've seen, it will pop up a browser where you can now be able to write your codes. But before then, let's save the file. Let's wait for it to pop up the browser. It's launched already. So once you hit the Jupyter Notebook icon, it pops up a browser. And then let's say I locate my location. Then I open a folder called LISFN. Yes. You open a folder. Let's say I have this file on title. If you look at it, you see that the notebook is saved as click here, you can rename it. Let's see example 1, or let's see week 1. Week 1. You can see that the file extension is what? IPYNB. You know, Py means what? PY means Python. So IPython notebook. Okay? So that's what this IPython refers to. Python can be run interactively, used extensively in research, and we've seen how it looks like. I don't need to waste my time with it. We've seen it practically. This is the nature, or this is how it looks like. Okay. Let me delete some of this. Okay, you write your codes in cells. Huh? You print hello world, for example, and you hit run, you see your result here, isn't it? So this is how the IPython looks. It's very interactive. And why do we prefer it? Is because it has this easy use environment, it's web-based, it combines both text and code in one place. I've shown you that, isn't it? In fact, I've shown you that apart from text and code, you can even add pictures, yeah? And it comes with a great number of useful packages. So, once you launch the notebook, it brings up this, yeah? And then if you have any particular folder you want to open, you just go and hit that. If you open that, if there are files inside it, what do? You simply hit that file and open it, isn't it? Just like I did here. I simply went, isn't it? I was here earlier, isn't it? I came to LISFN, opened it, and then I identified this with 1, isn't it? Because I have already opened it earlier. What if I want to open a new file? Maybe in this FM folder there isn't any folder, any file, and I want to open another one. You just hit here, run, go, and hit Python, isn't it? And then it opens a new file here for you. And then you can save it. Let's see, week 1B, isn't it? And then you can now see it. So you have 2 files, week 1 and week 2, week 1 and week 1B. So you can open any file of your choice. And these are some of the things we've seen. The diskette icon is for saving. If you want to add a new block, see it now. If you want to add a new block, you can just come here and click this plus, isn't it? Yeah. If you want to save whatever you've written, you can just come and save. If you want to cut or copy, if you want to move a block, for example, you have this block and you want to move it down, you can just come and hit this arrow, isn't it? If you want to move this down, you want to move it down, you want to move it down, up. Yeah. Stop execution. You know what this means? As you write, if you write a code, notice this place. What's happening here? It says the kernel status is idle, meaning it's not doing anything. If the kernel is busy, it will be black. For example, let me print the first 100 numbers or first 10 numbers. Let me see. Notice I have just written Python code here that does what? It prints the first number, okay, let me say it prints the numbers from 1 to 10 inclusive, and after printing each, it waits for 2 seconds, isn't it? You know, here was earlier idle, isn't it? this, what happens? It becomes black, isn't it? Meaning what? It's busy. And it will not become white until when this code is what? Has finished running. So I have 6, 7 now, 8, 9, and 10. Is that okay? It's now what? It's now free. But as you write programs, as you write Python programs, you can either erroneously write a code that will refuse to come out of the loop, what we call infinite loop. A code that continues running forever and ever. It's possible. Or for example, if I put if I put 1 million here, if I put 1 million here, if I run this code, now, when do you think this code will finish running? Yeah? So for so we're talking about, so you see, this can take you more than, it will take you probably, let's do the math. Let me stop it. Let me see, 1 million. Times what? Times 2 seconds, what? Times 2 divided by, because it's in seconds now, divided by 60, divided by 60. Let me run this. Divided by 24, isn't it? So if I am to run this now, if I am to run this code now, this code will not finish running until after 23 days. Should we try it and just come back after 23 days? You get it? This place will keep on being busy. It will only become idle after 23 days. So if you probably wrote a code and you wrote this in error, isn't it? Of course you don't want to stay here for 23 days. So you can come and hit this place. Interrupt kernel. And once you do that, what happens? It will now prematurely stop running the code. It's clear, right? And I've also shown that you can either write code or markdown, isn't it? Markdown is for writing notes. And then the code is where you write your code. And if you want to open a new file, you're working on a file and you want to open a new notebook, you can just come and create a new notebook. And if you write your code and you're happy with it and you want to download the book, you can just come and see download as either HTML, LaTeX, Markdown, notebook, etc. Okay? If you want to extend and clear output, these are some array of many useful functions, so you can play around with them. Okay? If you want to open a new folder or a new file, you can also do that. If you want to rename, if you want to upload the file somewhere, you can just hit that upload and then it will now select where you want to put it. Nobody says if you want to run the code, you must hit this one. Maybe 10 times 10, and then you hit run. There is a more elegant way. You can just hit shift and enter. Is that okay? So if you hit shift and enter, what happens? It runs a block. If you hit alt plus enter, it creates a new block, isn't it? So that's a shortcut to now having that. So if I run this now, let me delete this. If I run this, let me clear everything. Once we shift and enter, it runs this. Shift enter, it runs this. Shift enter, it runs this. So let's start. So if you like to follow along, you can open your own notebook, or please try to keep up with your presentation, because you still have time to try that at home after the teaching. Sorry? No Jupyter. Then go and install it now. Go online and type download Jupyter. You can't see Jupyter in your list of icons. So we can use Python as an application, isn't it? Huh? You've seen some of the functions yesterday. And apart from that, you can save any number or any string into a variable. Maybe if you say x is equals to 5, you are saying keep this number inside 5. For example, if you have something like this. X is equals to 5 or 10, and you see y is equals to 20, and you see print the sum of x and y, and you hit run and enter. What happens? You see the result. What are we saying here? We're saying this number 10 here should be kept where? Inside a variable x. And then this number here should be kept inside the variable y. And then you can now use the variables as opposed to using the raw numbers. So you can now print x and y. So you can now run this to see our result. That's what's happening here. We have a variable here. It's keeping the number 403. And then we have the miles to kilometer. This value. Good. Okay,
let me have some. Use the
So this was a simple exercise task. You know, mathematically, if you have a distance in miles and you want to convert that to kilometers, what do? You multiply by this number, 1.60934. That's the conversion, no? If you want to convert miles to kilometers, you simply multiply by 1.69. So once you have a distance into a miles and you want to convert that to kilometer, you simply multiply that by this. So remember here, this is both 03, and then this is 1.60934. So to get this now, we simply multiply this which has earlier been defined as 403 by this, which is defined as 1.60934. And you see that the result is actually the product of what? This and this. Okay, this is another example. So once you define a variable, you can use it anywhere. For example, you have, let's say here we have x, right? You can call anywhere and call x again, and you see that it still retains its value, unless if you update the value. For example, if you say x is now 9, and you run this, if you run this, x is 10 here. If you come and run this, x is 9. So if you call x or you print x, x will take the most recent value, which is what? Which is 9. So every number you have, every variable you have, has what we call a type. And that defines the way it is stored, isn't it? If the stuff you kept in the variable is a number that has no decimal point, we call that an integer. If it's a number that has decimal point, we call that float. If it is a string, that's characters, A, B, C, etc., we call that a string, str. And if it's a Boolean value, that's a number that's either true or false, we call that the bool, B-O-O-L. And then if there is nothing in the variable, then we call that none. If I say x is equals to 7.6, and I run this, if you do type x, what are you doing? You are asking Python to tell you what type of variable this is, isn't it? And what should this return? That's the answer. 7.6. It's a float. A number that has decimal points, we call them float. So we have floats here. If I have y is equals to 1099, this and I type int type y. It's an integer, isn't it? If I say y is equals to 5 is greater than 6. What is y now? What is y? Y is false. But the type is what? Is bool. So if you type y now, y will be what? Y will be false. Why? Because 5 is not greater than 6. However, if I'm to modify this to 15, 15 is now more greater than 6. Yeah? So the type will be what? The type will still be bool, but y is what? Y is true. It's clear. So why should we care? Why should we care to know that a variable is either an integer, a float, a string, a boolean? And why is it necessary? Because in Python, the operations you perform depends on the type of variable. Okay? For example, I can come here and say x is 7.6 and y is 6.99, and I say print x plus y. If I run this, I have what? I have 14.59, summing in 7.6 and 6.99. What if I do like this? If I say z is Python. If I run the what happens? You get an error, isn't it? You get an error. So if you run this, sorry, I didn't add zero.
Yeah.
You get an error. Why? Because in Python, it is not allowable to add a string and a float or integer or any numerical value. Because numerical values can take either integer or float. It's not allowable in Python to add a string, and so that means it's important for us to know the type of what? Of variable we are working with. So just like we have in this example. Here we have x to be what? X to be. Sorry, please let me shift one down. Thank you. So what do you have here? X is 10. What's 10? It's an integer. Y? What is 20? Look at it. Y is 20. Is it a string or a float or an integer? Sure. Y is 20. Is it a float, integer, or a string?
A string.
Yeah, 20 is an integer, but we enclose that in quotation. So regardless of what we have, whether it's a number or not, once we enclose that in quotation, we are telling Python to treat it as a what? As a string. So as far as Python is concerned, this is what? This is a string. So when you try to add x and y, what happens? You get error because you cannot add a numeric value and a string in Python. Okay? So important lesson to remember. We can't do arithmetic operations on variables of different types. Therefore, make sure that you're aware of your variable types. You can find the types of a variable using type, isn't it? And we've seen that. Now, if we are really determined to add this 10 and 20, where's my order? I'm really determined. I have x is 10 and y is 20, but in a string format, and I want to add x plus y. If I run this, I get error. If I'm really determined to add this x and y, I can do what we call casting. C-A-S-T-I-N-G. So long. What is in my download that is green? arranging now. I'm already arranging. This reason. There seems to be nobody else. So we can cast. Cast means converting temporarily one variable to another so that we can perform some operation.
Yeah, no. It's bad.
So we can cast. Meaning we know we can add a number and a number, isn't it? And what's our problem here in the addition? Is it x as our problem or y?
Y.
So we can cast y, isn't it? You can just convert y to what? To a float, isn't it? Or an int. What are we doing? They're now saying, hey, convert y to an integer and add that to what? And add that to x. And if you do that, you get what? You get that. It's clear. That doesn't make x, that doesn't make y to be an integer. If you do type y, you see that y is still a string, but you only casted, you only converted the y value temporarily to a format that will allow you to perform the addition.
So the way you just casted now is just addition of.
Yeah, just this string. I only added this. So because y is it's a string.
Yes.
And we cannot add a string and a number. So we're saying convert this y to an integer temporarily and then add to x. So that's the casting. Okay?
But the casting is not just specific to just integer.
No. You can cast as a float. You can float.
Okay.
But here in this case, when you get 30.0, isn't it? You get 30.0. You can even cast to string, isn't it? Yeah? But already here, y is a string, so you can just cast x to a string, isn't it? And if you do this, what happens? What should be the result?
Error is going to have two different.
You have to have the both numbers together.
Yeah.
When you apply the plus sign, when you add two strings together, you are not summing them, but you are performing what we call concatenation in Python. Concatenation. Okay? So if you do this, you get what? 10, 20. So we've seen casting. We have 10, 20, then you can now int it. And whatever we've done, you can do that to integers, floats, and even to strings. So, what will be the result then? Mark, what's the 10, 20. Why? Because both x and y are what? Are strings. If I want to add 10 and y, if I want to add them, I know that 10 is a string, y is a string, 20 is a string, but I want to add them. What do I do? I cast x, I cast y. It should be what? It should be int x plus int y. Is that clear? Yeah, so let's look at the basic arithmetic operations in Python. So plus is for
Yes, sir.
yes. Somebody wants to ask a question from online? So plus is for addition. Minus is for subtraction. Slash is for division.
Like the slide, I don't know. Maybe it's my network that here.
What's happening? It's not.
It's not moving. But I don't know if it's my network.
Is it moving now?
I don't know if it's my network, but I just started.
Those joining virtually, confirm that my slides are moving. Are they even hearing me? Just type message. Ask them that. Confirm it. So asterisk is what? Multiplication. Double slash is what? Floor division. And then asterisk is what? Odd. And you know, when you have a combination of plus, minus, slash, asterisk, you know the order of precedence follows. Just like we have in board maths, no? Huh? Board maths, isn't it? Even though in Python we don't use board maths, we use what we call pandas. Pandas. Is that okay? Pandas. Pam. Pandas. When you have a combination of various arithmetic operators and there is no any bracket that is confining or restricting the ones you do first. So the first one it does is to check if there is a parenthesis. There's a bracket. So it implements whatever is inside of the bracket first. And then if there is what's this? Sorry, PEMDAS. Not PEMDAS. PEMDAS. Not PEMDAS. So this is what? Exponentiation, isn't it? Exponent, isn't it? Exponent. That's basically powerful. Then multiplication, division, addition, subtraction.
So it's not moving for one.
It's not moving. So I have something like this. 16 asterisk 2/4. According to PEMDAS, you know, here you have two options, isn't it? If you begin with the slash, what will be the result? It will be 2/4, that's half. And then 6 raised to the power of half is 8. And 16 raised to the power of half is 4. Isn't it? But if we begin with the exponentiation, what happens? It will be 16 times 16. That's what? That's 16. 160 plus. Sorry, 16 into 10 plus. That's what? 16 times 16 divided by 4. That will be 16 over 16 divided by 2 times 2. That's 8 times 8. That's 64, isn't it? 64. So the first thing we do here is to do what? This one, huh? We do this one first. After this, then we do what? Then we do everything. Okay? After that, then we get the result. But what of this? Let me confuse somebody. Let me confuse somebody. Let me confuse somebody. Two times. Huh? Slide is long. Two raised to the power of what's the answer? This is 2 raised to the power of 3 plus 3. What's the answer? So it doesn't matter whether these ones are close, but you know, visually, it can deceive you to say, okay, 3 plus 3, 6. And then 2 raised to the power of 6 is what? 64. That's not correct. According to PEMDAS, like we've said that Python is space friendly. So this space doesn't mean anything to Python. Yeah? So it starts with 2 raised to the power of 3. That's what? 8. Have you? Then 8 plus 3 is what? 11. It's clear, no? But if you are really determined to start adding 3 and 3 before taking the exponent, then what do? You use bracket to now close whatever. So that's the key. That's the key that we have, parentheses. So if you have parentheses, you are forcing Python to start implementing what? The one inside that. Then the result is now. So we have 2 raised to the power of.
So like you are not online now. Come back online. It's too cool.
Network is not.
You won't know it. People leave it like this, call until we go. Just hold it there. Just hold it there.